Hello everyone, in this video we are going to write down the Lewis structure of chlorite ion. To write the Lewis structure of a molecule or ion, we need the total number of valence electrons in the molecule or ion, and therefore let us first count that. Atomic number of chlorine is 17, and therefore the electronic configuration is neon, that has 10 electrons, and then 3s2 3p5. Neon is the core, and therefore we have 7 valence electrons in chlorine. Atomic number of oxygen is 8, therefore the electronic configuration is helium, the 1s2 core, and then 2s2 2p4. So we have 6 valence electrons in oxygen, but we have 2 oxygen atoms in chlorite ion, therefore 6 times 2, and that is equal to 12. For the negative charge, we need to count 1 electron, and therefore this is 7 plus 12 plus 1. So in total we have 20 valence electrons in chlorite ion. Chlorine is less electronegative compared to oxygen, and therefore we are putting the chlorine atom at the center, and then 2 oxygen atoms on either side, and then 1 bond pair each between chlorine and oxygen, and then let's put 3 lone pairs around each oxygen atom. So if we do that, then basically we accounted for 16 valence electrons. We still have 4 more valence electrons, isn't it? So far we used 16 valence electrons, we still have 4 more valence electrons that we are going to put around chlorine. Now if we account for the octet configuration, then each atom satisfies the octet configuration here. Both chlorine as well as oxygen atoms do satisfy the octet configuration. However, we need to check the formal charges to decide whether this is the best Lewis structure or not. Formal charge is equal to total number of valence electrons in the atom minus total number of lone pairs of electrons, that is the non-bonded electrons in the molecule, minus total number of bond pairs divided by 2. So for chlorine it would be 7 valence electrons in the atom minus we have 2 lone pairs here, therefore 4, minus we have 2 bond pairs, and therefore 4 by 2, and this will be equal to 3 minus 2, and that is equal to plus 1. So if we are adapting to this structure, then we have to put a formal charge of plus 1 on top of chlorine, and then for each oxygen atom let's calculate the formal charge. Valence electrons in the atom for oxygen is 6, minus we have 3 lone pairs, therefore 6 again, and that would become 0, minus we have 1 bond pair, therefore 2 by 2, therefore this will be equal to minus 1. So we have to put minus 1 formal charge for both oxygen atoms, even though the net charge we are getting it as minus 1 in this case. This is not the best Lewis structure, because in the best Lewis structure the formal charges should be close to 0. So let's send 1 lone pair to the bond pair. Now if we check for the octet configuration, chlorine will have 10 electrons around it, which is okay because chlorine is in period 3, and therefore it has access to d orbitals. Therefore expanded octet is okay for chlorine. So now if we calculate the formal charge for chlorine, then it would be valence electrons 7 for chlorine, minus we have 2 lone pairs, so 4, minus now we have 3 bonds, isn't it? We have 3 bonds, and therefore 6 by 2, therefore 3 minus 3, and that is equal to 0. Now we are getting the formal charge as 0 for chlorine, and then for this oxygen we would get it as minus 1, but for this oxygen if we calculate the formal charge, then it would be 6 minus we have 2 lone pairs only now, this one and this one, and therefore 4, minus we have 2 bonds, therefore 4 by 2. Therefore, this will be 2 minus 2 and that is equal to 0. So, this gives the net charge as minus 1, and also for 2 of the atoms we are getting 0 as formal charge, and therefore, this is the best Lewis structure for chloride ion. For negative ions, we usually put square brackets around it. So, finally, if you are writing the Lewis structure, then to specify that it is an anion, it is better to write it this way. You can put the double bond either way. Let us not forget the lone pairs that are there on chlorine. So, this is the best Lewis structure for chloride ion.